Okay, here's question 4. Give it a try. Okay, the solutions to question 4. So given the following diagram, here's our graph, y equals f of x. Write down the value of f at 1. So this is the value of the function at 1. So I look for the x value of 1, and I figure out what value the function has. So I go, there's my x is 1. What value does the function have? Has 3. So f of 1 is equal to 3. This is the reverse. This is saying the f inverse. So instead of looking for x is equal to 2, because it's the inverse, I'm going to do the reverse. So I'm going to try to find the function at 2. So when does f of x hit 2, which is right here? And then what's the x coordinate that goes with that? That's 0. So that's the value there. The other way to look at it is once you have the sketch drawn, I've sketched the inverse here, f inverse at 2, I see this 0 there. So a couple ways to tackle that one. B says find the domain of the inverse. The domain of the inverse is the range of the function itself. So I'm going to take a look at the function, and the range of it is -2 up to 4. So I can write that as -2, 4. I've seen it written like this, but usually the way we write it is we use the set builder notation, and we write it as the range, the set of all y, such that -2 is less than or equal to y less than or equal to 4. This basically says y sits between -2 and 4, and y is any real number. And then part C says sketch the graph. So I think the easiest way to sketch it is I put down this line. This is the line y equals x. And I know the inverse function is just a reflection in this line. So you can just pick off 2 or 3 points and just reverse them and replot them. So this point here is -2, 0. So the inverse, which is the reflection over the line y equals x, has to be 0, -2, which is here. 0, 2 becomes 2, 0. 1, 3 becomes 3, 1. And then 4, 5 becomes 5, 4. So you can plot those points. And the point, interestingly, the point that hits the line y equals x doesn't move. It kind of reflects over top of itself. It kind of teeter-totters itself over that spot. So that point actually wouldn't move. Okay, that's it.